Okay, the whole point of part A is to calculate the magnitude and direction of the man's force. We have already established the direction. He must be pushing up because this object left to itself would accelerate down the hill based on the part of the weight that pulls it down the hill, this weight parallel. So he must be against the weight parallel, so he is pushing uphill. So now we know his direction. What about the magnitude? The magnitude of this man's force is equal to the magnitude of the weight down. So if we understand how much of this weight is pulling down the hill and how much is against the hill, we can immediately answer how much he's pushing. I'm going to use geometry to figure out these sides, and I'm going to make a declarative statement right now that this angle in there is theta. And the rest of this video is a geometric proof of why that's theta. People who believe me or just want to memorize it can quickly jump to the next video, but I'm going to tell those people right now that when you draw this, when you know the angle of the slope, you're going to have to consistently identify this triangle with a parallel side and a perpendicular side to this face and know that that is theta. Those two angles are the same. Anybody who wants to see a quick, maybe 2-minute proof, stand by. Otherwise, skip to the next video. So I'm just going to redraw the diagram so I don't muck it up. We have angle theta there. We have our weight vector. We've broken up the weight vector into part of the weight that's pulling against the hillside and part of the weight that's pulling down the hillside. That's parallel to the surface. This is perpendicular to the surface, and this is our original weight as the hypotenuse of this triangle. So if I just slightly extend this weight downwards, weight is certainly perpendicular to the horizontal, and this is a triangle here, and interior angles all add up to 180 degrees. So this must be equal to, so theta plus this angle is equal to 90. So this must be equal to 90 degrees minus theta. And if that angle is equal to 90 degrees minus theta, and this is perpendicular to this surface, then those two angles must add up to 90 degrees. So this, if that's 90 minus theta, then this must be theta. So I just identified that as 90-degree angle. That is a 90-degree angle, so that's a 90-degree angle. And if those two angles together are 90 degrees, if I know that angle, I know that angle. And these two angles are 90 degrees. So anyway, it's pretty simple once you see it once. And for the future, we just need to be able to recognize that this little angle in here matches the angle of the slope. And if this thing starts to fall flat, this squeezes together, as you would expect. And if this becomes steep and this angle opens up, then this triangle will open up as well. Okay, we'll solve the math next video.